Today we'll discuss another new chapter of modern physics, that is nuclei. We have already discussed one chapter of modern physics, that is atom, and in this chapter we'll study about the constituent of the nucleus and how they are held together. We shall also discuss various properties of the nuclei such as size, mass, density and stability of the nuclei, and also associated nuclear phenomena such as radioactivity, nuclear fission and nuclear fusion also. This nuclei is nothing but the plural form of nucleus. So we have to know about the nucleus. First, already I have told you about the nucleus, that nucleus is nothing but the central core of every atom, where whole of the positive charge and almost whole of the mass of the atom is deposited, and especially the size of the nucleus is very small as compared to the size of the atom. When the size of the atom is 10 to the power minus 10 meter, there the size of the nucleus is 10 to the power minus 15 meter order. So the nucleus is very small as compared to the size of the atom, and especially the nucleus constitute of two parts, that are protons and neutrons, and these proton and neutrons are combinedly known as nucleons. We can say them nucleons. So the two particles contained in the nucleus known as nucleons combinedly, and we have to know more about that proton as well as neutron. First we have to know about the proton. Especially the proton has mass, that is 1.6 into 10 to the power minus 27 kg, and charge on the proton is 1.6 into 10 to the power minus 19 coulomb. The number of the proton contained in the nucleus is the same as the atomic number Z of the element. That means we can say the proton number is nothing but the atomic number, and it is represented by the symbol Z. And neutron has mass 1.6 into 10 to the power minus 27 kg, and charge on the neutron is 0. That means it is the neutral particle. So this is the constituent of the nucleus. Now how a nucleus is represented, we have to know. Suppose X is the symbol of the substance, chemical symbol of the substance. For suppose hydrogen, helium, lithium, like that, uranium, like that, and it is represented as XZA. In below left side we have to write Z, and above left side we have to write A. Here the Z is the atomic number, that is number of the proton, and A is the atomic number, atomic mass number, that is one is atomic number Z and A is the atomic mass number. Atomic mass number is nothing but the sum of the proton number plus neutron number. This atomic masses, what is atomic masses? Especially when we want to measure a heavy quantity, heavy amount of substance, we have to use the units just like kilogram, gram. To more bigger quantity we have to measure, we will use quintal, ton, etc. But when we just want to measure a very smaller quantity such as the nuclear mass, mass of the atom, and since the mass of the atom is very small, kilogram is not a very convenient unit to measure small quantities. Suppose we want to measure a very small quantity, we cannot measure it. Suppose we want to measure our height, we cannot measure it. We can measure, but it is not convenient, it is not suitable to express our height in kilometer. We are measuring our height in feet. Like that, the mass of the atom is very small, so kilogram is a very convenient, not a very convenient unit to measure such small quantity. That means kilogram is not suitable to measure the mass, atomic masses. Therefore, the unit in which atomic and nuclear masses are measured is called atomic mass unit, and it is expressed as U in the symbol U. And this atomic mass is defined as 1 by 12th of the mass of one atom of carbon 612 isotope. And how we can express it? The atomic mass unit is expressed in the symbol U, and the mass of 6.023 into 10 to the power 23 atom. That means this is the Avogadro number. You know, the mass of Avogadro number of carbon atom. That means 6.023 into 10 to the power 23 atoms of carbon 12 equal to 12 gram. So 1 AMU, we know 1 by 12th of the mass of one carbon isotope. So 1 AMU equal to, 1 U means you have to understood that is 1 AMU, 1 atomic mass unit, equal to 1 by 12 into 12 by 6.02 into 10 to the power 23. That will give us 1.66 into 10 to the power minus 27 kg. And in terms of this unit, in terms of AMU, we can express the mass of an electron. We are writing here by the symbol ME, M subscript E, that means mass of electron, equal to 0.000 means 00055 U. AMU also you can read AMU. And mass of the proton MP, M subscript P, that is 1.0073 AMU. And mass of the neutron Mn equal to 1.0086 AMU. Why we are expressing it in AMU? AMU is the smallest unit which is expressed to show the masses of very small quantity, but also this can expressed in the unit EV, that is electron volt, because in Einstein's mass energy formula that the mass can converted into energy. In that case, these masses of electron, proton and neutron can also be expressed in terms of electron volt. Later we will discuss that, but you have to remember one thing, the masses of electron, proton and neutron in terms of this unit, that is AMU, atomic mass unit. Next come to atomic number. We have already discussed just in the previous cases that atomic number is the number of the protons present inside the nucleus of an atom, and it is represented by the symbol Z. Similarly, the mass number is the total number of the protons and neutrons present inside the atomic nucleus. That means we can say the number of the nucleons. Nucleons is nothing but the sum of the proton and neutron. So the atomic mass number A equal to proton number plus neutron number, N is the number of the neutrons, Z is the number of the proton. The term nucleon is used for proton or neutron. So the number of the nucleons in an atom is its mass number A. And we have to know one thing, that a free neutron is unstable and has a mean life of 1000 seconds. And when a free proton is stable, because neutron is unstable, its life period is just 1000 seconds, and neutron is however stable inside the nucleus. When the neutrons are inside the nucleus, they are stable. If we bring it to outside, then it is unstable, and its lifetimes is just 1000 seconds. This thing you have to remember about that neutron. Next come to another three factors, that are isotopes, isobars, and isotones. I think you have already well known in these three factors in your chemistry classes in atom chapter. So first thing is isotopes. What are isotopes? Isotopes are all the nuclei with same atomic number but different mass number. If nuclei are there, they have atomic number same but mass number is different. Hydrogen has three isotopes: deuterium, protium, and tritium. Protium is not written here, only two is written, that is deuterium H12, hydrogen 12, tritium, that hydrogen 13, protium hydrogen also we can say. And gold has 32 isotopes ranging from A173 to A means atomic mass number 204. Carbon has also different isotopes. So you have to remember one thing, that Z number is same of the atom of the same nuclei having Z number same but A number different. A means atomic mass number is different. Next come to isobars. The nucleides with the same mass number A but different atomic number are known as isobars. The nuclei which have same atomic number but same mass number A but different atomic number, just opposite of these isotopes. That means Z number is different, A number is same. Atom of different nucleides, just like hydrogen 13. Here one example, so many examples can there, but I have taken here one example, that hydrogen 13, H13, and helium 23. Here you will notice one thing, that number A number is same, that is 3. This is also 3, but Z number is different. For hydrogen, Z number is 1, and for helium, Z number is 2. Next come to another factor, that is isotones. Isotones is nothing but the nucleides with same neutron number but a different atomic number. Here we have taken one example, that is Hg 80 198 and R means gold 79 197. This is hydrogen and gold. So here the neutron number, in each case we have to calculate. Here the proton number is 80, here the proton number is 79, and we will calculate the neutron number. As you know how we will calculate the neutron number, A equal to Z plus N, so N equal to A minus Z. Here 198 minus Z 80, that is become 118. Here also for AU 197 minus 79, that will become 118. So in these two cases, for Hg and for AU, the neutron number is same. So that are the isotones. Next come to one problem basing upon that theory we have discussed already. So the problem number 1 is like this: a nucleus has atomic number 11 and mass number 24. State the number of the electrons protons and neutrons in the nucleus. One question is given you that a nucleus has atomic number. Atomic number means Z is given 11, mass number is 24, that means A equal to 24, and we have to calculate the number of the electrons, protons and neutrons. We know inside the nucleus electron is not there. Actually electron is there inside, means in atom revolving in different orbit, but it is not inside the nucleus. So since electron is not inside the nucleus, so the number of the electrons in the nucleus equal to 0, and because electron do not exist in the nucleus. And I have taken that the atomic number means proton number, that is Z equal to 11 and A equal to 24, and number of the protons in the nucleus, but we know A equal to Z plus N, so N equal to how much? A minus Z. So A value is 24 minus 11, that is equal to 13. And next problem is like that: select the pair of isotones from the following nuclei. Here different nuclei are given, just like magnesium 1224, hydrogen 13, helium 24, sodium 1123, and you have to choose the pair of the isotones. First you have to remember that one thing. What is isotone? Isotone is the elements having same number of the neutrons. So you have to choose here which elements have same number of the neutron. And hydrogen 13 and helium 24. You just see number of the neutrons here for hydrogen. This is A, this is Z, and N equal to A minus Z. So 3 minus 1 equal to 2. And for helium, that is 4 minus 2 equal to 2. So the H13 and He24 means helium 24. These are the isotones. These are the pair of the isotones. Similarly, Mg1224 and sodium 1123. These are also the number of the neutrons. Here for magnesium, the number of the neutrons is 24 minus 12, that is 12. And for sodium means Na, 23 minus 11, that is 12, because here A number is 23 and Z number is 11. Next, another problem is there that select the pairs of isobars and isotones from the following nuclei. This is for you. I have given some ideas, some hints to solve the problem. Isobar means same mass number and isotones means same number of the neutrons. You have to select from this pair that which are the isobars and which are the isotones. You will select your own. If you cannot solve, then ask me on WhatsApp. I will told you. And come to next question. I have given this is the task for you. You have to solve it. No, nothing, or it is very small questions. A nucleus has atomic number 11. Atomic number is given, Z equal to 11, and mass is 24, means A is given 24. State the number of the electrons, protons and neutrons in the nucleus. Here also I have given some hints, some ideas, that electron do not exist in the nucleus. When electron do not exist means it must be 0. And number of the protons here given, atomic number, that is Z equal to 11, and number of the neutrons you will calculate your own, that is N equal to A minus Z. I think everyone can solve it. If you cannot solve, then ask me, I will solve it. I think everyone can solve it because it is very easy questions that I have already discussed in examples. So next come to characteristics of nucleus. Characteristics, so we will discuss about the charge, volume, radius, density. These are the characteristics. So first we have to study about the charge on the nucleus. charge on the nucleus, inside the nucleus, protons and neutrons are there. Neutron is chargeless, we have already know. So only the charge of the nucleus is provided due to the proton, and proton charge is nothing but 1.6 into 10 to the power minus 19 coulomb. So this is the charge of the nucleus. Then come to size of the nucleus. And it has been found by performing the scattering experiment, in which the first electrons, instead of the alpha particles that bombard target made up of various elements, that a nucleus has mass number A, has a radius. It is just the experimental observation that the radius is directly proportional to the means atomic mass to the power 1 by 3. So R proportional to A to the power 1 by 3, or we can write R equal to some constant R0 A to the power 1 by 3. R is nothing but the radius, A is the atomic mass. So R0 equal to 1.2 into 10 to the power minus 15 meter. And the volume of the nucleus is given by, volume we know, nucleus is a spherical in structure, so the volume is 4 by 3 pi r cube. So 4 by 3 into pi into r cube. R cube r0 A to the power 1 by 3 whole to the power 3. This 1 by 3 cancel. So it will be only A, but r0 cube. That r0 is 1.2 into 10 to the power minus 15 whole to the power 3. It will become 7.23 into 10 to the power minus 45 A. This atomic number is here, A meter cube. So this is all about.